Hello, champ. I hope you are all fine and studying well. In this video, I am going to discuss about the fundamental and the derived units. Before that, I will be defining what is physics. So we know that physics is a branch of science in which we study the laws of nature. In this branch, the nature and its laws are described quantitatively and qualitatively. The quantitative study of nature involves the estimation and measurements of various physical quantities like distance, weight, temperature, etc. So the question is, how do we measure physical quantities, okay, and what are the units in which we measure them? So measurement is a method of comparison of an unknown quantity with a standard quantity. This fixed or definite quantity which we take as a standard and by the help of which we can measure other quantities of the same kind is defined as the units. So there are two main types of the units. The first category is called the fundamental and the other one is called the derived units. So fundamental units are the basic units upon which other units depend. They are the units of the fundamental quantities. Okay, the fundamental quantities are the basic quantities that are independent of others and cannot be defined in terms of other quantities or derived from them. They are the basic quantities upon which most of the quantities depend. There are three fundamental physical quantities. These are the length, mass, and time. Length may be defined as the extent of a space or distance extended, whereas mass is defined as the quantity of matter or material substance, and time is defined as that in which events are distinguishable with reference to before or after. Let us now see what do we mean by the term derived physical quantities and units. So, derived quantities and units are those obtained by some simple combination of the fundamental quantities and units. They are thus dependent on the fundamental quantities and units. Now we are going to discuss about the system of units. At different times we have different system of units for measurements of physical quantities. The earliest system of units was called FPS system, in which length was measured in foot, mass was measured in pound, and time was measured in second. Then came the CGS system, okay, which is also called centimeter gram second, in which length is measured in centimeter, mass is measured in gram, and time is measured in second. Then came the MKS system, which is basically meter, kilogram, and second, okay, in which length is measured in meter, mass was measured in kilogram, and time is measured in second. Today we are using SI system. SI is the most important system today. It is used to be called the MKS system. The SI system consists of 7 fundamental units. So let us now talk about the fundamental units and the fundamental physical quantities and their units. So the 7 fundamental physical quantities are as the first is length. Its unit is meter and has a symbol m, a small m. Then the next fundamental physical quantity is time. Its unit is second and has a symbol s. Then it is the third quantity is mass. Its unit is kilogram and has a unit kg. Fourth fundamental physical quantity is electric current. Its unit is ampere and the symbol is capital A. Then is the temperature and its unit is Kelvin and has a symbol K. Then sixth physical quantities is amount of substance measured in mole and has a symbol MOL. Finally, the seventh fundamental physical quantity is luminous intensity and has a unit candela, okay, which bears the symbol Ct. So these were the 7 fundamental physical quantities. All other physical quantities, okay, can be interpreted in terms of these fundamental physical quantities and their units. So let us now talk about some examples of derived physical quantities, such as area. Area we define as the product of two different dimensions. Okay, for example, area equals to length into breadth. We know that length and breadth are basically some kind of length and has a unit meter. So length into breadth, which means meter into meter. So the SI unit of area is meter square. Next, let us take an example of density. We know that density is defined as the quantity of matter, okay, per unit volume. Basically, that is mass upon volume, and we know that mass has a unit of kilogram, and volume, since it's the product of three lengths in different directions, so that is kg upon meter cube. So the density of SI unit, the SI unit of density is kg per meter cube. And let us now talk about the speed. We define speed as distance traveled per unit time, and we know that distance has a SI unit of meter and time has a unit of second. So speed has a SI unit of meter per second. Let us now take one more example of force. We define force as product of mass into acceleration. We know that the mass has a SI unit of kg and acceleration has a SI unit of meter per second square. So the force has a SI unit of kg meter per second square, which in short we know as the Newton. So 1 Newton is 1 kg meter per second square. Besides this fundamental and derived physical quantities and their units, we have two supplementary units. Okay, the one is called the plane angle and the another one is called the solid angle. Plane angle refers to the angle in 2 dimensions and the solid angle refers to the angle in 3 dimensions. So plane angle, it is defined as the angle subtended at the center of a circle by an arc equal in length to the radius. Okay, so plane angle is defined as arc length divided by radius. So theta is equals to L upon R, and its SI unit is radian and has a symbol RAD. Whereas solid angle, it is the angle subtended at the center of a sphere by surface of the sphere. Solid angle omega is defined as surface area divided by R square, as I have shown in the figure. Okay, and its SI unit is steradian and has a symbol SR. Let us now talk about some common SI prefixes. Okay, we know that physical quantities may be of larger magnitude and a smaller magnitude. Okay, based on that, we use some prefixes, okay, to represent them. So we have, let's start with the smaller physical factors. Okay, if we have a factor of 10 to the power minus 1, it is called deci. A factor of 10 to the power minus 2 is called centi. A factor of 10 to the power minus 3 is known as milli. A factor of 10 to the power minus 6 is known as micro. A factor of 10 to the power minus 9 is known as nano. A factor of 10 to the power minus 15 is known as femto, and a factor of 10 to the power minus 18 is known as atto. Let us now talk about some bigger prefixes, such as 10 to the power 1 is called deca, 10 to the power 2 is called hecto, 10 to the power 3 is called kilo, 10 to the power 6 is called mega, 10 to the power 9 is called giga, 10 to the power 12 is called tera, 10 to the power 15 is called peta, and 10 to the power 18 is called exa. I hope you understand all these concepts. You understand the meaning of fundamental and derived physical quantities and their SI units. If you like our videos, please follow me on Facebook and Instagram on my page Handwritten Physics Notes. And if you are watching this video on YouTube, you can subscribe to my channel Comparative Physics. Thank you very much for watching.